Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through everything you need to know about trigonometry for your upcoming test. So trigonometry is used to find sides and angles in triangles. We're just looking at right-angled triangles. So to help us know which of the ratios to use, we have our acronym SOHCAHTOA. You use sine if the question involves opposite and hypotenuse. You use cos if it involves adjacent and hypotenuse, and you use tan if it involves opposite and adjacent. Feel free to put this on your cheat sheet. Feel free also to put this on your cheat sheet. You use sine, cos, or tan button on your calculator if finding a side. You use sine inverse, cos inverse, or tan inverse on your calculator if you're finding an angle. So to get these buttons on your calculator, you normally need to press second first, depending on your calculator. So I'd press second sine to get sine inverse, or second tan to get tan inverse, and so on. So let's look at these two questions. First, we're finding an unknown side in right-angled triangles. So my first step is to decide which ratio to use. So in this question, I have my reference angle here. It's never the 90-degree angle. This is the reference angle. This side x is opposite, and I also have the hypotenuse. So opposite and hypotenuse, I use sine in this question. In the second one here, I have the opposite and the adjacent. This is the hypotenuse. So when you have opposite and adjacent, you use tan. So that's step one done for both triangles. So sine, cos, and tan are functions. They need what's called an argument. They need a number. Sine doesn't mean anything by itself. It has to be sine of a number. So it's always sine of the angle, and similarly tan of the angle. So sine of the angle equals opposite over hypotenuse. I know the opposite goes on top because it's listed first in the SOHCAHTOA acronym. So sine 30 equals the opposite x over the hypotenuse 10. Here, tan 42 equals opposite over adjacent. So opposite 12, adjacent y. Opposite goes on top because here it's on top in the SOHCAHTOA acronym. So now I have to solve each of these equations, and this is why I decided to do them both at once, because I really want to highlight the difference between these two. The difference is here we have the thing we want to find on top, here the thing we want to find is on the bottom. When the thing you want to find is on top, you times. So I would put x equals 10 times sine 30 in my calculator. And assuming you've got the right mode, make sure you're in degrees mode, the answer is 5. That is the length of this side here. On the other hand, when the thing you want to find is on the bottom, you divide. So to solve this, I'm going to put on my calculator not 12 times tan 42, 12 divided by tan 42. And again, making sure our calculator is in degrees mode, we get about 13.33. That's to 2 decimal places. So the thing you want to find is on top, you times. Thing you want to find is on the bottom, you divide. Let's now look at this question here. So this one's different because now I'm finding an unknown angle. So to find an unknown angle, I still need to decide which ratio to use. I have the adjacent side and the hypotenuse. So I'm going to use cos. But because we're finding an angle, I need to use cos inverse. So cos, according to this acronym, is adjacent over hypotenuse. So on my calculator, I'm going to put cos inverse of adjacent on top, hypotenuse on the bottom. That is what theta will equal. Now, normally, when we're giving angles in trigonometry, we give to the nearest whole number. So if we put this on our calculator, we get about 36.87 degrees, which is close to 37 degrees. All right, let's now look at some applications of trigonometry. So there's 2 applications you need to know, the first of which is angles of elevation and depression. So let's try this question. From a point 100 meters from its base, the angle of elevation to the top of a building is 39 degrees. Calculate the height of a building. So whenever you are given a worded question in trigonometry, draw a picture. What we have is some building over here, and we're talking about being at a point 100 meters away. Now we're told the angle of elevation is 39 degrees. So we draw a line here making a right angled triangle, and one of the angles is going to be 39 degrees. Now the angle of elevation and depression are always the angles made with the horizontal. It's this angle that is 39 degrees, not this angle in there. That is not the angle of elevation. Just note that the angle of depression from the top of the building would be this angle up here, made with the horizontal. The angle of elevation and angle of depression are always equal because they're alternate. So just make sure you know angle of elevation and angle of depression are always the angles made with a horizontal line. So the question asks us to calculate the height of the building. So I'm just going to call that x. We've actually done all the hard work in drawing our diagram. Now we've just got a right angled triangle, and we're going to find x just as we did on the previous slide. So we're going to use tan because we have opposite and adjacent. So we have tan of angle equals opposite on top, adjacent on the bottom. Now, because the thing I want to find is on top, I multiply. So x will be 100 times tan 39. You just put that in your calculator, making sure your calculator is in degrees mode. And so we get about 80.97, which is close enough to 81 meters tall. That's how tall the building is. So that's one application that you need to know, angles of elevation and depression. The other is bearing. So let's look at that now. So I travel 90 kilometers east, 130 kilometers south. On what bearing must I travel to return to my starting position? So again, even if you have no idea what the question's saying, let's just start by drawing a diagram. Because you probably know if I start here, this direction is east. So I've got 90 kilometers east. And then I've gone 130 kilometers south. There'll be a right angle here because east and south are at right angles to each other. So always make sure in your diagram that there is a right angled triangle. So we're going to join this up so it's a right angled triangle. Okay, I started here, I ended here. I need to find the bearing from here to here. So what does it mean by bearing? Well, remember, bearing, when we go north, east, south, or west, is a way for us to know exactly in which direction we're going. Because if I just say, walk northeast, does that mean you go up here, or up here, or up here? We give each direction an angle, then there's no ambiguity in which direction you go. Remember that it always starts at the north axis, that's 0 degrees, and we go clockwise. So due east is 90 degrees, due south is 180 degrees, due west is 270 degrees, and then back up to north is 360 degrees as well. So if you go 0 degrees or 360 degrees, you are going true north. Okay, so how does that help us with this question here? Well, what we need to do, if we're here going here, we need to know this angle here. So let's find out what this angle is. We can just use simple trigonometry. Once again, I have opposite and adjacent, so I'm going to use tan, but because I'm finding an angle, I'm going to use tan inverse. So opposite goes on top and adjacent on the bottom. I just put it in my calculator just like that. So if I put that on my calculator, I end up getting about 35 degrees to the nearest degree. So that's this angle here. But it's not actually the bearing. What then would be the bearing? Well, remember, bearings, this is going north. From here up to here is north. So we want the angle made with the north axis in a clockwise direction. We actually want this whole angle here. That will give us the bearing. And we sort of know that. To go from here to here, we need to go in a northwest direction. We need to go in this direction. So our answer's got to be between 270 and 360. So what will this green angle be? Well, the whole way around is 360. So the green part will be 360 minus 35. The bearing will be 360 minus 35, 325 degrees. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.